Hi, in this video I would like to explain how to apply the equations of motion to a horizontal plane as well as to a vertical plane. First we draw a sketch, and here you can see a horizontal plane example. A block is moving from left to right, and we must fix the initial conditions and the final conditions. When you do that, you can see that the initial time instant is t initial and the final time instant is t final. And the gap between them is the time interval t, and I stress on that word interval. Between those dotted lines passing through the center of the block, you have the displacement equal to s, and the initial velocity is u, and the final velocity at t final is v, and the acceleration of the block is shown here as a. So we'll use only three equations to solve all the variables. The final velocity v is equal to u plus at. The distance traveled, or the displacement in a straight line, is equal to ut plus half at squared, and v squared minus u squared equal to 2as. These three equations must be remembered. And if the object is decelerating instead of accelerating, remember to put minus a instead of plus a in these three equations. And then you'll be able to solve any problem that comes in front of you. Now we apply the same thing to a vertical plane motion. We have a block and the center line is marked. It's dropped, it's not thrown down, and it falls down as shown by the dotted line. And you can see that between the center of the block, top and bottom, the displacement is s, or the height h, and the time interval is t, and the acceleration is gravity. So since the acceleration is gravity and nothing else, v equal to u plus at becomes v1 equal to u1 plus g into t. We simply substituted g instead of a. And u is 0 because we just dropped it, and therefore v1 becomes equal to gt. Coming to the second equation, s equal to ut plus half at squared. So therefore we simply put h equal to u1 into t plus half gt squared, and that becomes 0 plus half gt squared. The third equation, we follow a similar philosophy. V squared minus u squared equal to 2gs becomes v1 squared minus u1 squared equal to 2gh. And we know that u1 is 0, therefore v1 squared becomes 2gh, or v1 equal to root 2gh. That's how we have derived this. Now if a ball is thrown upwards, the main thing to remember is that it's acting against gravity, so the acceleration equal to minus g, or the deceleration is g. And the ball, or the object, will always come to a standstill at the top of its flight before it starts to fall down again. So the displacement is, as usual, s, or height h, doesn't matter what symbol we use. The time interval is t. So v equal to u plus at simply becomes u0 equal to u plus at, because the final velocity is 0 here. That's the important thing to imagine in these kind of problems. Therefore 0 becomes u1 minus g into t, therefore u1 equal to gt. So we simply substitute minus g for a. The second equation, s equal to ut plus half at squared, becomes h equal to u1 into t minus half g into t squared, because it's going upwards. And v squared minus u squared equal to 2gs becomes v1 squared minus u1 squared equal to 2gh. That's 0 minus u1 squared equal to 2gh, therefore u1 squared equal to 2gh, or u1 equal to root of 2gh. So therefore it's easy to derive these equations and apply them to various problems rather than trying to remember them. I hope this video was useful to you. Thanks and have a great day.